Hello, Professor Lohman. This is Andrew Trace. This is my project, my Rube Goldberg project, and now I'll give you a layout of the whole thing. Okay, hold on. The camera isn't. Okay, there we are. So we start off. First step, we do the potential elastic energy from this launcher will launch this car and create a linear motion. We then will go around a circular motion at a certain point in the center. It will rotate with an acceleration equal to v squared over r. Then from there we get to step 3. We get to projectile motion, where the car launches the ball from a ledge. It will fall with a parabolic curve. Although theta equals 0 whenever it falls, we have theta equals 0 when it falls. It will start at half the parabolic curve when it falls to hit the dominoes. Dominoes is vibrational motion. It goes in a wave-like motion, and it will run into, each domino will fall into each other, causing kinetic energy to transfer and knock over this tower. Now here's the domino tower. We have a paper clip on top of it. The tower is going to fall, causing the potential energy from the that it has, and it will cause it to fall from the once the domino tower falls, it will transfer kinetic energy on, and then the kinetic energy, there will be a force applied by tension, and the tension force will cause this other paperclip to fall. It's attached to a string, and it will cause this marble to fall. And as we know, it has components from the force of gravity on it. It has a y and x component, and the ramp will go across the ramp linearly. It will go from ramp to ramp inside through this box. This box has a hole in it. It will fall into this ramp. It will go along until we get to the next step, which is more dominoes. The dominoes will knock over, and it will knock into the tower. The kinetic energy transfer from the tower will take the potential energy from this object, and it will cause it to fall, turning the potential energy into kinetic energy. It will transfer that into the string, which the string will have a force of tension that causes this jack to fall, which will then trigger a rotational motion that starts from this point, a point right from on the ceiling, and the pencil will rotate about a certain point until it hits into this cardboard triggering device which we've made. It has a domino in it, so whenever a force is applied to the cardboard, there is it causes this propeller to rotate a circular motion. A circular motion will occur, and the potential energy that is located at the top of the propeller will fall. It will cause a tension force in the rope, and it will trigger this a mousetrap, which is a form of rotationary motion, circular motion, and it will pop this balloon because it rotates at one point across a single point, around a single point, and then it will knock into this balloon. The balloon will pop, fluid will fall through this cylinder and into the tube. These little straws get smaller as they go towards the soap. causing a greater pressure in the water. The soap will then have a rotationary motion from the fluid motion, and it will fall into the sink linearly. It will linearly drop into the sink, and that is my soap drop project. Now we're going to get into trying it and looking at where it is failing and where it is succeeding, and we'll be right back with that. Testing the Rube Goldberg project.
And we had to pull the string.
You have to pull the string.
And it did not click it. And we are hitting this one.
We're hitting this trigger. Running into difficulties, as you can see.
Speaking.
The tower fell over that was holding the water.
In previous test runs, it did not.
In previous test runs, it shot the water into the soap and was effectively able to do it. This has caused a lot of devastation to the project. As you can see, it was working well for the beginning half, and then we had some troubles. Okay, so we demonstrated how the project is working so far, what we've built, each step that we've taken. Some changes that we made were that we added an extra step with the propeller to try to trigger the mousetrap. So we did an extra step there, and that's what some of the changes that we made. But we have some good parts that we're going through, which it's kind of going up and down now. We did good in our last trial for the first about eight steps, and then the last steps we had some trouble with. But on a previous trial, the last steps worked, and we were having trouble with the beginning steps. Getting the ball to land with the dominoes was difficult, but we did it. So we have our successes and we have our failures. One of the main failure is that because we did the back half, we did it successfully during one trial by accident, and we noticed that we have a trigger mechanism for the paper box that we used for the pencil to hit the paper box to trigger the propeller, and use that potential energy and turn it into kinetic energy and create tension in the string. So we used a different box because in the previous, when we did the half successfully, and the water went through and spilled onto the soap, it was successful. And then the problem that we had was that the paper we had whenever it worked, it blew water everywhere. The water balloon exploded. Water got on the cardboard, and the cardboard, we had to get a new piece of cardboard, and that one was just too stiff, so it was not moving right. And so to remedy this, we're going to try to use something more pliable, something that will move more easily, not be so stiff. We got to work on that trigger mechanism for the final to really make sure we get the back half down. We also have to work on getting the ball to land on the dominoes more repetitive. We need to have a more concrete way of getting the ball to land at the same spot each and every time. More repetitive success. So we have that to work on, And yeah, we have our successes and we have our failures so far, but we're still gonna work on it until we get to the final and have a flawless flawless project. Well, thank you. That's been our Rube Goldberg project so far. This is stage 2, and we'll see you at stage 3.